All right, welcome everyone. Thanks for coming to see my session. Hope you've been having a great day. And sure enough, today we're going to be talking about building microservice REST APIs. So my name is Chad Green. I'm Director of IT Architecture for Galena Solutions. I'm going to say, I'm getting an echo in my ear. That's going to drive me crazy. So sure enough, there is all my contact information. Definitely feel free. I put it on there. If you want to reach out afterwards, definitely do so. I'm also an MVP, and sure enough, quick little plug, I do run Codepalooza down in Louisville, Kentucky, so that'll be in August. All right, so sure enough, the title, Building Microservice REST APIs Using Azure Functions. Could I have picked any more keywords in one title? I'm not so sure, but these are actually some really big topics that you could easily talk a whole hour just in each one. And I do want to make sure we set the stage and understand what we're talking about. So first off, microservices. What are we talking about? Well, if we look at the way how applications have always been developed, we had this monolithic architecture. And, the name has been, made a bad name. And monolithic apps in and of themselves are not necessarily a bad thing, but they're not great at scale and so forth. And also, a lot of times, I heard for years, oh, we're not doing monolithic because we have an N tier, right? We're doing these. And I'm like, yeah, you still have everything interconnected. And that's really what we meant by that monolithic. And when we talk about, trying to build something more distributed. And that's where microservices came to be. So sure enough, now you have your user interface or interfaces that are talking to these microservices, which are basically, you're taking your business domain and you're breaking it apart to logical areas and then serving up that area with your microservice. And then those microservices will talk to their own database. Now, this is a little bit of contention in the software industry about whether you have a separate database for every microservice or a database across. I admit, it depends on what I'm building as to what I will do. With that being said, I will say where I'm at right now, we're using one big database and we are feeling the pain. Right? For example, the deployments are now an issue because now I have to make sure that we don't step on top of anyone else. I won't tell you one way is better than the other, although I will say a lot of times the separate databases definitely do make a difference. But all right, so why go into microservices? What are the reasons? Well, number one is the fact that they are quick, and quick in a lot of different ways. One, you can generally develop them a lot quicker because you're building just a small piece of code, right? You're not building the whole architecture of everything that's needed to be done. You're focused on that one thing. But also because your code is focused on one thing, the code itself is generally quicker, right? Because you're not having all the dependencies of all the other systems in there. I mean, you ever had any framework model that, or a context that has everything for, like 8 different systems? I do, and you know what the problem is? Every time it loads, it's so slow. Right, so that's one of the things. We have one big database, but we broke apart the entity framework context so that I'm not loading it every single time. And that's, again, part of the advantages of microservices. Next is resilience. And honestly, this is one of the biggest reasons why I switched my architectures to microservices is that resilience. The idea that, think of it like an order processing system, right? If you have a system that's doing, taking the orders in, doing the fulfillment, doing the notifications, just because fulfillment went down, I still want to take orders in, right? As a business, we don't want to stop taking orders. Grant you, it's not great the warehouse is getting behind, but and that's where we get this a benefit, right? In a monolithic architecture, if it's all together, that fulfillment goes down, there's a good chance it brought down ordering. And that's where we get some benefits here. Next one is scalability, and these kind of go together. Obviously, if I have resilience, I also get better scalability because now I can scale just the parts I need to scale to the levels I need to be. Again, if you think about the order processing system, that order module probably needs better scalability than fulfillment, right? Again, you don't want your warehouse waiting too long, but if they have to wait a couple seconds for an order to come up, so they can pick it, that's not as bad as taking a couple of seconds to place an order, because most likely people are going to leave. Next is maintainability. Because I'm building something smaller and more compact, it's definitely a whole lot easier to maintain. I'm only having to maintain a smaller piece. And then finally, flexibility. And there's a lot of different reasons for this flexibility. One, again, because I'm focusing on one thing, that can specialize in doing what it wants to do. But more importantly, I don't have to have it all the same language. Think of where you need something that's doing machine learning, and where everything else is CRUD, right? Well, your CRUD, C# or Java makes a lot of sense, but a Python app might make more sense for that machine learning. Well, with this, with the microservice architecture, because everything is its own component, I can build in these different languages or different technologies and so forth. So, and there are some disadvantages of microservices. We'll get into a little bit of that, but I really want to focus on the advantages. So next, I wanted to talk real quick about REST, because REST gets talked about a lot, and we all say we're doing RESTful services, but usually when I ask people what do they mean by that, they really don't know what it means, or they know one little piece of what REST is talking about. And number one, I usually don't have people who even know what REST stands for. So it's the representational state transfer. And basically this is an architectural style, so it's not actually an actual technology, because as a matter of fact, you can use any type of technology to apply it. But the biggest part of it was it defines a set of constraints to meet in order to build good web services. And the cool part, this was actually a doctoral dissertation from Royal Fielding back in 2000, so it's actually been around for quite a while. And part of the reason why he came up with the name was actually to invoke this idea of the behavior he wanted to enforce. So if we look at the idea of REST, here's what we're talking about. You have your client and your server, and your client sends over this request. And you see in here that address that I've got in here, StirTrek.com, speakers, Chad Green. Now that is not a RESTful service, so don't actually, but it worked well and it tied with the conference, right? But the point is we have this URI that it easily identifies what I'm trying to get to. Obviously, I got StirTrek, I'm getting speakers, I'm getting speakers for 2022, and then I'm dealing right down to Chad Green. So I'm sending that request over to the server, and then the server sends over a response. And one of the big deals, especially, you gotta remember, this is now 22 years ago, but 22 years ago, we were talking a lot about, where it's very dogmatic as to the responses you had to send back. It was either SOAP or it's XML or some version of one of those two. With REST, the idea is you send back the response that makes sense for your customer, right? So a lot of times it's JSON, and everyone thinks that REST automatically means JSON, but it doesn't, right? It could be XML, it could be HTML, SOAP, it could be images. Right? So something I just deployed a couple weeks ago was actually a service that resizes your images. So it's actually returning back the image that you want to hit. And by doing all this, you get this response back that then the customer can do things with it. So those constraints, I talked about that there's these 6 constraints. The first one, the one that most of us all understand, the client-server architecture. And there's really not much to this. Sure, if you go, it's a doctoral dissertation, so obviously it goes really deep. But in reality, we're just talking about the fact that there's a client and there's a server. They don't necessarily know about each other than the fact that there's a request and there's a response. That's really what we're talking about in here. The next one, this is a big one, is statelessness. The idea that your services should be stateless. They shouldn't carry memory of the previous request. And the reason why this is actually a pretty big deal is will build up your resiliency. This will build up your scalability, because I no longer have to worry about storing that memory. Along with that is cacheability, right? The fact that we're caching responses, and we have that ability to cache that response, whether on the server side or the client side. And the biggest reasons for this is really to help reduce the latency of responses, but also, in the end, the cost of responses. So sure enough, I just released a listing service, for a major senior living organization. And they're averaging about 54,000 calls a day to this API. Well, we're caching that. So out of 54,000, I think yesterday, if I look, I remember it was like 1,500 of those requests actually went back to the back-end service. Everything else was cached, right? And by doing that, I'm not hitting my Cosmos database as much, which means my Cosmos bill stays really low, which keeps my CTO very happy with me. And that's all that really matters, right, is I keep my CTO happy. All right, the next one is the fact a layered system. And really, I think this kind of goes along with the client server. But really, the point we're talking about here is that the client, all it knows is calling to, quote unquote, a server. But it doesn't necessarily know how many layers deep it's going in, right? Because most likely, we've set up a gateway in front of everything. There's a proxy, there's a cache server, you know. So the actual processing might be several layers deep. But the point of this constraint is that we don't need to know that. All we know is we're sending in that URL that gives me what I want and gets me back the response I'm expecting. The fifth constraint, which is actually an optional constraint, and I've actually never seen it implemented, is this whole idea of code on demand. So normally when we think about services, we're thinking about, okay, you request me for something, employee details, and I give you back a response with that details. Code on demand actually takes a step forward and actually will send back like a Java applet that can then be run on the client. So you're actually modifying what the client does. Now, like I said, I have never implemented this, so I can't really talk more about it other than what the constraint is. And you even notice that it's listed as optional, so it's not something you have to be implementing. And then finally, uniform interface. And sure enough, this is what everyone thinks about when they think about REST. The idea, you know, you remember back that Star Trek address I gave, and I broke it down, right? You know, it's the domain, the speakers, 2022. What was it? Oh, and Chad Green, right? So the fact we have that uniform interface. The point being is, like if you know, if Joe Smith is also speaking, I hit the same address just to replace Joe Smith instead of Chad Green, and that's where we're getting that uniform interface. Along with the other big part is the verbs, right? So now I label this as REST verbs, but these are actually using HTTP verbs. So nothing was created for REST to make this happen. It was already part of the HTTP protocol. That's actually a double word, but anyway, but it's part of the protocol. And basically REST is using what's already built in there. And so to go through these real quickly, because I usually see a lot of people get confused on which verbs to use. So first, if we look at a CRUD system, you know, we have post. So sure enough, here you see a request, right? So post to this example API to employees. So and I'm in the in the request body, I'm sending over the data in an agreed upon format, most likely JSON that has the appropriate fields. And that will actually trigger the server to create an employee with that record, right? Now, the other important part is the responses. And now, with that being said, I'm actually saying that you should always follow this, but at the same rate, all it really matters is that you and your customer agree upon the responses that are being sent. But these are generally good recommendations. So number one, on a create, on a post, you send back a 201 if it's successful, which is created. And actually nothing else in response body. And the biggest reason is because you don't need to send anything back in response body. The customer told you what the data was, so there's no need to send it back, because all you're doing by doing is sending back more data than they need. Now, one of the things you normally will do is if the server is the one that defines the identifier, then you'll actually send back a content location header that actually gives you the address of the GET for that. And in here you see some normal failure codes. So like a 400 for a bad request, for maybe there's a field that's not in the right range, or it's missing, or what have you. And then, since this is a crate, if it already exists, then you should return back a 409 if it already exists. And sometimes you'll get some debates on this. It's like, oh, just return back a 201 because it was still successful. The record was already there. The reason why you normally return a 409 is because there might be a problem. Maybe I expected, or maybe I didn't expect that record to already exist, and now all of a sudden, it already was there. So it helps us do some troubleshooting later on. So that's the reason why you will normally use a 409. Now I will say, there's also, a lot of times I'll actually put a query string value of like a creative, I'm thinking an update. I'll talk about that in a moment. All right, so moving on. Next one would be get, right? Again, I'm going the order of CRUD, right? So being able to read. And sure enough, you'll see something similar to this, right? So get employee or example API / employees. And in theory, that's going to give you the list of all the employees. That's funny. I was actually giving this talk last week, and someone said, "Well, I hope that's a small company." You know, actually, he and I worked for the same company where there was 130,000 of us, so I got what he meant by that. But sure enough, normally you'll page the data if there's a lot. But point is, here you see where I'm getting everything, or I'll have a /ID that will give me the ID. So where I'm asking for a particular employee. In here, if we think of the status codes, this is more obvious, right? It's a get operation. If you didn't realize about normal HTTP, get is like 99% of what you're doing on the web. But so sure enough, you're going to return back that 200 OK. Pretty unusual to have a bad request, but maybe you do. Maybe there's some filtering that you're sending in the request, and they send a bad filter or what have you. But then sure enough, if it's not there, then you should return a 404. Although I will say, if it's a list, right? So if I ask for all the employees, and if there is no employees, which again, that might be a problem for a company. But if there was no data, you actually should return back an empty list. That is actually more correct than a 404 or nothing. Is actually an empty list, because that serializes correctly and so forth. All right, next one. So we want to do an update. So that's a put. And here again, you'll see that I'm saying employees. I'm saying I'm going to update this ID. And in the response, or I'm sorry, in the request body, I will send the message that contains what I want to update. And sure enough, here you can see a couple different possibilities for responses. Number one is your normal one is a 204 no content, because again, you're returning no response. You shouldn't even have to send back the content location. Although I have some systems that I've done where the customer has asked us just always send back the content location, so we'll do that. But by protocol, that's not necessary. Now, I've also seen, this is where I was talking about a moment ago, a lot of times they'll ask us to do basically an upsert. So that's where you'll see, I checked that it didn't exist, so we created it, and I'll return back a 201. And again, making sure I let the customer know exactly what we did. And again, you'll see these normal status codes, a 400 for a bad request or a 404 for a failure. Now, a little bit less used is the patch, right? And this is also doing updates, but technically this is doing a partial update. And sure enough, if you don't want to confuse people who know deep into the HTTP system, don't do patch if you're not doing a partial update, because they will expect that. And there is a little bit different ways how things work when you're doing partial updates. But this is very similar to what we saw with a put. Again, I'll return back a 204, no content, or the normal responses. And of course, with all good things have to come in, so there's the delete. The URL looks very much like we've seen before. And again, here you'll see like a 200 if it was successful. I will say, even if it existed before, it now longer exists, you should return a 404. Because again, it's letting the customer know that it was already deleted. Now, on the customer side, a 404 is not necessarily a bad thing. You have to handle that correctly. All right, so moving on. The next big keyword, serverless. And sure enough, I do hold hour-long presentations on serverless, but I'm going to go through this real quickly. And I normally like to start talking about the evolution of application platforms. We all started with the on-premise. Sure enough, if you got gray like I do, luckily I have blonde hair, so you don't see my gray. But I definitely have gray hair because I've been old enough. I did a lot of on-premise systems, and there was a lot of things we had to do in order to build an on-prem system. First, we had to get the hardware. And if you worked for big customers like I did, that usually took for months just to get a piece of hardware, right? But you had to get the hardware. You had to figure out the operating system and get those installed and keep those patched. You also had to figure out the development framework you're going to use, get the right versions and get those patched. Somehow you got your code onto the server, because normally when I'm talking about days, this is before Git was a big thing. And so, a lot of times a source code repository was a floppy disk that developers would share around. I have actually done that before. But then somehow you actually get all this code on the cloud. if you thought getting the hardware was hard, getting it on the cloud was sometimes the even harder things. But the thing was, is once we had this all done, we weren't complete. There were a lot of things we had to figure out. How we were going to do backups, physical security, scaling, monitoring, and so on. So all these other questions that have nothing to do with building an application, but all have everything to do with keeping an application up and running. And as an application developer, these are way out of our realms, right? This is not really what we want to deal with. This isn't where our expertise is, but we got involved so much with this. So sure enough, the cloud came to be, which I always find funny because the cloud's been around for what, about 20, 25 years, but in reality, it's been around since like the 60s. Because actually, like I used to work for EDS, and that's actually how EDS got started. It was, Ross Perot was actually a sales guy for IBM, and he was selling these mainframes that weren't being used at night, and so he was on the side, he was selling access to it. So really, cloud's been around for a long time. But at any rate, when the cloud got started, we really started with this, IaaS, infrastructure as a service. The idea now that, I don't have, physical hardware in my data center. It's in someone else's data center. And sure enough, this did make things better, right? One, I'm not having to run my own hardware. But two, a lot of times, all those questions we had to ask were at least more organized, right? Because a lot of times they would put them in buckets of places to answer and so forth. But still, a lot of questions that have nothing to do with how to handle my customers' needs. We move along, and then we get to the platform as a service. This is what we think more of nowadays, and now the questions have gotten a lot fewer. Because now I don't manage the actual hardware, I'm just managing basically a virtualization of that hardware, and just really all I care about is like the web service of it and so forth. But there's still some really important questions, most importantly, scalability and reliability. And then that's where serverless comes to be. And the idea here, and I just remembered I still haven't put that font on this laptop, so all you get is a bunch of question marks. I saw that last week and I completely forgot to change that. But at any rate, the idea now we have this serverless, the idea that I don't have to worry about the servers, I don't have to worry about the operating system and everything, I just need to worry about my code. Now of course, this name is pretty stupid because obviously there are servers. Right? But the thing is it's not that there aren't any servers, it's just that you could think about the servers less. And that's really where, actually I don't think that's really where people thought the name at first. I think that was kind of after the fact, but it's actually really good to think about it, right? Because I no longer have to worry about server configuration, server scaling. Most of the solutions I deploy are serverless, and I don't even know what version of the operating system we're using. I'll know that it's using either Linux or Windows a lot of times, but I don't even know what version. Now, with that being said, actually, I dig a little bit deeper into Microsoft world, so I do know, but I don't need to care about it. So, some benefits. Well, number one, what we've been talking about, no server management. I don't have to worry about this. Which means I don't have to worry about its updating. I don't have to worry about it, staying online and everything. That's up to the vendor to take care of it. One of the biggest things is simplified scalability. So before, it wasn't hard, right? Especially if you look at a platform as a service offering. A lot of those made scalability very easy, right? I could say, okay, if I hit this level, I want to scale up to this much. But I still had to make a lot of decisions beforehand. And I didn't always make the right decisions, right? And usually we were either, we bottlenecked and we didn't scale enough, or we scaled too much and we were paying for more than what we needed. Whereas with a serverless world, I don't put any configuration in there. Again, it's up to the vendor. And especially when we get into Azure Functions, it's even more so. All I do is put my code out there. And really, because of a lot of this, I get lower cost. Because I'm usually only paying, not usually, I'm only paying for what I use. So if I have a service that maybe it's only used 4 hours of the day, right? I'm only having to pay for 4 hours of usage throughout the day. I'm not having to pay for the rest of the day. But more importantly, maybe I have another type of service, like an e-com service, where during the holidays it gets used a whole lot more. Fine. But I didn't have to pay for all that additional bandwidth beforehand, like we used to have to do. There's also quicker turnaround. And a lot of this is because I'm writing a lot smaller amount of code, because I'm only having to write the code for that, what I need to run. So because of this, we can produce code a lot quicker, which also makes it simplified. And even more so, when I get into code examples, you're going to see this. My Azure functions almost have no code in them. They're actually calling the class libraries to do all the work. So some really good benefits. There are some disadvantages. Number one is testing challenges. It's not really a great way to test these. And especially functions as a service, which we're getting into, they get even harder because they're hiding a lot of things that would happen. It's funny, actually for years, Microsoft never documented what to do about how to test everything. And I did come up with here's the way how you should test it. And sure enough, I felt so good when they finally wrote documentation, and it was basically saying what I was saying. So testing can be hard. The next one is security concerns. And there's two parts to this. Number one, you're dependent on the vendor for everything in the back end, which means they're the ones responsible for keeping it secure. Now, that's a big benefit. I don't have to deal with it. Right? Again, I don't have to employ people that are managing all that. But at the same rate, I'm dependent on that vendor to make sure they're doing everything right. Now, when you look at the big three, big four of the cloud vendors, they're all going to do they're going to do a good job with that. But the other concern you have to be concerned with security is a lot of times you're running on hardware with other people's code. So memory leaks can be an issue. Now, even there, especially again with the bigger vendors, they're doing a lot of things to make sure that you're isolated and everything. And actually, Azure Functions has been doing a whole lot of work with that. But it's still a concern. It's still something you want to be careful of. All right, the next thing is that they are short running. That's actually one of the benefits. It's meant for very fast code, but there's limitations. For example, an Azure function in a standard mode, by default it can only run for 5 minutes, and I actually have to make a setting change where I can get 10 minutes. And that sounds like, oh, well, 10 minutes. Why would you ever have something run 10 minutes? Yeah, until you start writing some applications that all of a sudden need a long process that take a long time. So the short running process can be a disadvantage because it's not necessarily the solution for everything that you're doing. Next thing is cold starts. Because of the fact you've got a server that's starting and stopping automatically for you, that start can take a while. And when I say a while, it's not unusual to see something take 8, 10, 20 seconds. Which for a simple REST service where I'm just trying to get a list of employees, 20 seconds is horrible time. Because that's even before it does my code. Just the amount of time it takes to start up. There are ways to get around cold starts, but again, this is a disadvantage because you do have to think about that. And then finally, vendor lock-in. And sure enough, this is probably one of the biggest issues you have in here, although at the same rate, I say, is that really a problem? I usually get this, oh, well, okay, we're going to implement Azure Functions. Well, that's going to lock us into Azure. And I'm like, do you realize what it would take us to move from Azure, or using Lambdas, how much what it would take us to move from AWS, right? The fact that I'm doing one thing, yeah, it's adding to the problem, but it's probably not an issue. But with that being said, it is an issue. I will say there have been some attempts to make a cloud, independent type of serverless, and I noticed the biggest one was actually Service.com. And actually, I went and checked them a couple weeks ago, and now they're only offering AWS services. So I guess that didn't work out very well for them. So definitely some disadvantages, but again, nothing that I think would stop us. So with that, obviously, I'm talking about Azure Functions. I've already mentioned them a couple times. So some of the reasons why I run Azure Functions. Number one is you get this choice of language. So I can use the right language for the problem I'm trying to solve. Now, I'm a C# developer. I've been doing C# since day one. So most likely I'm going to write C#. And sure enough, you can do C#, you can do F#, JavaScript, but also I can do Java, I can do Python, I can do Bash, or really I can pretty much do whatever language I want because you can actually write custom handlers to handle your language. So I bet you there's someone running COBOL on an Azure function. I'm just willing to bet. And I bet you it's not probably here in Columbus since there's so much insurance companies here, right? But I mean, you do have that ability, right? And there's that freedom. And again, one Azure function can be different than the other. I can use different languages for these. Next is very much like serverless, it's a pay-per-use pricing, and usually very, very cheap. Now, there are a couple different plans you have to look at. First, the one we normally think about is the consumption plan. That's exactly what it sounds like. I'm paying for consumption. And there's two different metrics that are used for pricing. So first is number of executions. You actually get your first 1 million executions free, and that is per subscription, not for each function app. But so you get a 1 million free, and then you also pay for what they call the gigabyte seconds. So basically the amount of resources over the amount of time. And an example I usually use is like to do a 3 million requests per month function that's using, say, a half a meg of memory. I mean, that's a pretty typical load. That'll cost you $18 to do 3 million transactions. That's pretty good pricing. There are a couple other plans. They have their premium plan. There's a couple reasons why you would go to premium. Number one is you're getting premium services. They actually are running them on better servers. The other big thing, I talked about the cold start. Premium plan gets rid of the cold start. Most people who go to a premium plan, that's the reason why they do it. And the idea is, with a premium plan, is that your service never scales all the way down to zero, but you're not paying for that. Well, you are, because you're paying a bigger price for it per month, but it never fully goes down, so it always keeps something warm. You can also do it on an Azure App Service Plan. So the idea that same things like I use for a website, I can use for Azure Functions. And part of this is because actually Azure Functions is based off the ASP.NET engine. So they're utilizing that to run it on a service plan. Usually when I tell people to do this, there's two reasons. One, I have something, I really want to do this really long routine, and I still want to use Azure Functions. Well, on a service plan, there is no limit. It can run for as long as you want. But the biggest thing is if I have a service plan sitting around that's doing something but it's not being completely utilized, then I can actually use that and have no additional cost. But you also kind of lose on your scalability here. You can scale it, but now it's up to you and so forth. All right, move back to features. Next is this bring your own dependencies. The idea that I can use NuGet packages or I can use NPM and bring in my code. And sure enough, you'll see when we get into the code, that's actually how I write all my Azure functions. I put them in packages and bring those in. Like most everything in Azure, you have this integrated security. They make it very, very easy. Literally just click a couple buttons and I have integrated security, whether that be particularly OAuth. So I can do Azure AD, or I can do Google, Twitter, Facebook, Microsoft account, whatever you want, and it's all built in. Now, one of the big things that I think Azure Functions does better than some of the other competitors of it is this simplified integration. So whether I want to monitor changes to Cosmos database, take messages coming into an Event Hub, monitor topics within Service Bus, take in actually Event Grid, Service Bus, monitoring files that come into a blob storage, or even respond to a text message. These are all easy built in, and this is just a small sampling of the integrations they've done. And when I say built in, I mean it's usually one line of code that I have to do. And it's really just a decoration. It makes it so easy to do this. And like I say, this is, to me, one of the things that Azure has really excelled over, say, like an AWS. Every time I go into AWS and I see the integrations, they have some good integrations, but there's so many steps you have to take to make that happen. All right, next is flexible development. So, especially when we talk about the .NET world, I can use Visual Studio Code. If I'm sadistic, I can write code in the portal. Heaven forbid you do all that. But also, my code can be stored anywhere I need to be. Whether that be a GitHub repository or even old TFS, it will connect that. But also, OneDrive, Bitbucket, Dropbox, an external Git repository. These are all possible, right? And it's again built in easily to deploy that code out. And then finally, it is open source. So sure enough, they have open sourced this whole project. I will say, actually, the cool part is I don't have to run this on Azure. I can actually download it and run it on whatever box I want, and that's completely legit. the big reason why I like talking about the fact that Azure Functions is open source is the fact that when I have an issue, I can actually go into the GitHub repo and open up an issue on there, and I will get a response. I don't want to dog Microsoft tech support. This is definitely, with Azure Functions, this is the better way to get tech support. You know, obviously not for simple little things, but when you're having these crazy things happening, you definitely get a lot of much better support out of this. Talked about a little bit this, but this is, you know, not exactly the complete list, but most of the triggers and bindings. You know, Azure Functions is built on the whole idea, it's triggered off an event and then fires off a set of code. And you can see a lot of different you know, triggers and bindings that we can go off of. So really nice. All right, then one other thing I want to talk about before we start getting into some code, there's two different types of process models that are support with C#. I will say I'm a C# developer, so I'm going to focus on C# for the rest of this talk. But so up until .NET 5, everything was in process. And you know, I mentioned earlier, you have this issue that you are running alongside with other people's code, and that's part of what in process was doing. But really, this boiled down to because it was just easier for them to write it that way. You know, they wrote it in the same process that they're running the host that is running your code. When .NET 5 came out, originally, Azure Functions was not going to support .NET 5. And they're, well, number one, I will say the Azure Function team is a great team. They need more people, you know, because you know, it does take them a little bit longer, I've noticed, to get things out. But so when .NET 5 came out, they said, well, we're going to just wait till .NET 6, because .NET 5 was not a long-term release. It was a current release. As a matter of fact, I think it's next week, .NET 5 goes out of support. But so they were like, well, we're just going to wait. Well, the community said, no. We really want to go to .NET 5, and we don't want to wait a whole nother year for .NET 6 to come out. And they were really struggling with how they were going to do this. And so they came up with the isolated process. Now, they actually already had the isolated process. They just weren't using it for C#. Right? I should say they weren't using it for .NET, because it does support the other .NET languages. But like for their way how they're doing Java and Python is actually an isolated process. So it is running outside of the host. Technically a little less efficient, but they're actually, you know, they're making great strides to improve on that. The biggest issue with the isolated process, and this is, I prefer the isolated over, well, number one, I was writing a bunch of .NET 5 stuff, so I had to do isolated, and now I definitely prefer it over the in process. The biggest issue is that we won't have full support until .NET 8. So basically next year, next November, not this year, but next year. So sure enough, this is a roadmap. You can see, you know, so like you notice .NET 5 is up in the isolated process. Sure enough, .NET 6, they did release it for both isolated and for in process. Notice .NET 7 is only going to have a isolated process. The .NET 6 is going to carry through until .NET 8. And you might ask me, well, what's the big difference? The big difference is not all the triggers and bindings are supported in the isolated model. So there are times you have to go back to the in process in order to use some of the bindings and so forth. And actually, I'm going to be demoing one of those that is not supported yet in isolated. All right, so with that, let's actually get into the code. Let's take a look at what we're talking about. And sure enough, I've got this fictional company, Senior Living Systems, and basically, and this might sound very similar to what I do on a daily basis, but they're building software for senior living companies, all right? And so what they've done is they've built up this set of microservices, you know, portfolio management, managing the buildings and the rooms, resident management, care management, lease management. And they've built these microservices to support all these different ones in here. And then those microservices, we're not going to get into this part in this code, but they're using API management in front of everything, and the consumers are calling that. But for today, we're going to look at this portfolio management. And really, we're just going to look at a little small piece of it. We're going to look at you know, how we would do some of the CRUD operations in there, because it at least gives you a good introduction into Azure Functions, and more importantly, into the REST services. All right. So we've got our Visual Studio, and I'm going to explain this a little bit. And there we go. A little bit bigger. The one problem with Visual Studio, I cannot make the menus bigger. But I want to talk real quick about the solution I've got built up here. Ignore the fact that I have two different function projects. That's actually because I talked about one of the things I'm going to show you have to do an in process. That's the reason why I created two different ones. But you'll notice I have my entity framework stuff. So I have an entities class library. I have a repository class library. I usually will do that because I'm following the repository pattern. But then you'll see that services class library. That's actually where all the work is actually done. All right, so we're actually look at that, and then we'll go into these Azure functions. So sure enough, if I was to look at this, and there's really nothing all that special in here. So here we've got this class for community status, so the status of a community, so a property. And this is just typical CRUD operations. There's actually nothing Azure Function specific in here, partially because I'm doing it on purpose. That way I can use this code for other pieces, right? So like the web application can use the same code. It doesn't have to use something different. So sure enough, you'll see in here, now I am returning in a response body and I have a request body. They're slightly different than the actual entity. But it actually ends up going to this private method. You can see like I'm doing some validations, making sure you gave me the fields I'm expecting. I'm doing this try get, and if it did exist, I created this custom exception, object already exists exception. Biggest reason why I created a custom exception is just made it easier when I get to my Azure function, because I'll trap that and do what I need to do with that. But then everything else is just Entity Framework, right? I create the object, I add it, and I save it, right? And in all reality, I could have done this in a little bit smaller piece of code, do the add and the new and the same, but this is the way how I did it. And then now this method, you see I'm returning back the whole object because I'm using it internally. But again, when we get back to the method, we'll see that we're not returning it back. Sure enough, the other methods are very similar. The update does very similar logic in here. Again, checking the fields are there, doing that try get, and you'll notice here I have this, optional value whether or not to create it if it doesn't exist. The other big thing that I do is I'm returning the object, but I'm returning it inside of an update results. And the update results, here we can go to that real quick. All it's doing is I've got the update object, but then I have an update action. All right, so I'm basically telling whoever's consuming this class library what happened. All right. So then again, if we go back in here, you'll see I also do I check to see whether or not there are actually changes being passed in. Now, I will say, if you're just doing a web application, that's an expensive call that you might not need to do. But because we want to let the user know whether or not there really was an update, we're doing it in here. So we make that, and why I say expensive, it's adding microseconds, right? It's just doing simple logic. As you can see in the logic, if this doesn't equal it, then it has changes. And if it has changes, it makes the changes. So that's the code. So now let's actually get into the Azure functions. So here, I'm actually going to start with create a new Azure function just to show the process. So I'm going to add a new, try that again, add new project. You'll notice that Azure Functions is on top. Guess what I write a lot of. But so, I'm going to click on that. It doesn't matter. I'm not going to actually save this, so I'm not going to worry about the name. Should use a name that makes sense. And then you'll notice in here, I need to actually pick the framework I'm using. So, which does show you how far along. I don't know if that's going to work. No, it's not going to work while I'm not in presentation mode. But so you can see, supports all the way back to .NET Framework. There's .NET Core 2, .NET Core 3, you know, .NET 5 isolated, and you have .NET 6 and .NET 6 isolated. So, and normally I will do isolated. You'll notice here we have a list, decent sized list of options of what we can create. You'll notice if I go to the .NET 6, there's actually more. It's a little bit hard to see, but point is not everything is supported in the isolated. With that being said, my preference is if I can do the bindings I want to do, I will do it in isolated. I just think the programming model is a little bit nicer in the isolated mode. So I will select the type of trigger I want to do. So normally we're going to do an HTTP trigger. That's most Azure functions. You'll also notice that there's a storage emulator. And that's because actually the way how Azure functions work is they actually do need a storage account to store the code. So technically you might have to pay for that, but I've never seen an Azure function go over the threshold of what's included for free, because it's literally just storing the code. And then you also notice this authorization level, so basically that's saying where I'm going to authorize to use the function. I'll get a little bit more into that here in a moment. But we can click create. I'm not going to actually click create just because I don't need the project in here. But once that's done, in the isolated mode, we're going to do a project like this. The only thing different is we're going to see that we're going to see a function 1, the typical hello world function 1. So the next thing I want to show in here is the program file. This is one of the things that isolated definitely does a whole lot better is dependency injection. And you'll notice if you're an ASP.NET developer, this looks very much the same because it is the exact same model they're using. It is the ASP.NET model exactly. So I can do my normal dependency injections. You can see like I usually will set some JSON serialized options to make sure that I'm always passing the same formats. And I have my typical dependency injections. This one here, well actually these two are for something I'm about to show. So you don't always have those two in there. As a matter of fact, you'll notice that by default, it's just configure functions worker defaults. But because I'm going to show something with OpenAPI, and then there it needs the Newton soft JSON. Well, so once we have that, we can get into our Azure function. And in here you can see, now for this example code, I put all the CRUD methods in one class file. I will admit, normally when I'm writing stuff for production, I actually write them in separate classes, just because it's a little bit easier to find the code that I need. That's the only reason why I do it. There's no performance reason. It's just a matter of keeping the code a little bit smaller. But in here, you'll see normal dependency injection. We're creating the constructor with the objects we're passing in. And again, if we look, we'll start with the get. It's very simple. So we're doing async. Here, you'll see that trigger method. So that I'm saying I'm doing a trigger. Here's that authorization I was talking about. So you have three options. There's anonymous, which obviously means I don't have to pass any type of authorization. There's function, which basically means that there's a special code for each function app. I'm sorry, for each function within your app. Or there's admin, which basically means that you have one key for all the functions within a function app. I will say it gets a little bit different when you do the OAuth authentication, but we're not going to talk about it right now because it's really a whole other topic. The next part you see in here is, so I'm saying a get. So basically I'm saying this method will take a get response. You'll notice like down here I have a post. You actually can accept multiples. Matter of fact, if you look at the Hello World they build, it actually is a get and a post. So there is that. And then you see, and this route is optional, but I normally will specify this. And again, this is to give me my RESTful type, uniform interface, right? So in here I'm saying, give me a route of community statuses. I will say this is also a standard of, when you have your compound words, it's all lowercase, and you put a dash in between the words. And usually plural. But again, the important part is just be consistent across your app, right? However you want to do it. And then you can see we're going to get in this request data. I'm going to go in here, I'm going to call my backend service, do its get method, get that response back. And then I'm going to do this create response async. So sure enough, this is not a built-in method. So request that's the HTTP request body that's coming in. But I have written customized code to handle my responses a little bit better. And sure enough, that is completely open source. If you go to GitHub/tail-learn code, you'll find this repository in there. But one of the big things that it's doing in here, so for example, I'm passing in the object I want along with my JSON serializer options. So one, I'm able to pass in my how I want to serialize it. But the other important part is it actually has logic handling. So okay, it checks to see if that object is null. So if it's null, they'll return back a 404. If it's not null, they'll return back the object. So it's actually handling the response codes and so forth. If we go a little bit further down, here we see that getting a particular community status, and again, just seeing the way how the route works, I'm going to put in them curly braces, and then I will add a parameter that matches that, and it has to match by case also. There is that convention there. Sure enough, the crate. The other thing they're showing here is here you see I'm catching all those different catches. Everything else was the same, other than obviously I'm looking at what happened in the updates. But in my crate, I'm actually, I'm looking for those custom response codes, or exceptions, and returning an appropriate response code. So the other cool part about Azure Functions, I can run these completely locally. So if I ran this, you'll see a console app start up here. We would grab the URL that it created. Not there. Actually, I forgot to do Postman. If we open up Postman, we will see in here, this is why I meant to, so this is why I was supposed to start this before the session. Can I get to just create a request? It's because I'm not connected to the internet right now. All right, let's just, normally what I would do is I've never tried running this when I'm not on the internet. If we were just do like a simple get, so like if I was to run this get community status, so I copy, because I can do this on a web browser. So you'll notice this is taking a moment. That's that cold start. Even on a local machine, I still have a cold start. But then sure enough, I got back my response. So I can't show you all the other running because the browser doesn't let me do a response and request. But it's very simple, right? I send in the responses and I get what I expected. So we'll just focus on the code for the rest here. So the next thing I wanted to show in here, I'm going to stop that. Just is there? Leaving that, it's not. No, I wish I remembered. If I remember beforehand, I would have turned my phone on, hotspot, and actually probably if I did it long enough just so it was connected at the beginning, it probably would have been fine. But at any rate, so that was great. We did something, but now there's also the Open API spec, which is basically a way to document your APIs. And I will admit, I like the older names, Swashbuckle and usually, Swashbuckle to generate your Swagger. And I loved the first time I had to go to a meeting with the CEO of a company and tell him, oh yeah, we're using Swashbuckle to generate our Swagger. And he looked at me like I was completely pulling his chain. And that's really what it was. So sure enough, there is an extension into Azure Functions. I do have to add in this, forgot the name of the package. It is Microsoft Azure Functions, Worker, Extensions, Open API. But once I've added it in there, thank you, I get these additional attributes I can add in here. So you see in here, Open API operation. I give the ID of the operation, give it a description. You can see that my key that's used in here. I can give information about the response body to include what type of object I'm responding back with. All right. So it builds all this out. It also has a way to do an example code in here. I don't have that in here. It also supports multiple response bodies. So in here, this is a create, so there's different responses we can return based upon what happened, to include like my errors and so forth. So sure enough, if I was to run this, again, it's the same function app, so you see everything will come up and running. And now, if I go to the browser and I click the address, and here's where I get this. I am going to run this again. And if you've seen Swagger before, this is nothing new. It's just the fact that now we're actually generating this with Azure Functions. And the nice part is I now have self-documentation. And the other nice part is other things can use that Swagger to understand what's coming in. So if you remember on my slides, I was showing like this example project I've been building is also using API management, API management. API management will actually understand all that and bring all that information in there so that the developer portal is really easy to use. And also you can test everything out with these, right? So I can click execute and it will actually execute that method, and I got back a response. The one thing I will say with it, if you remember, you pay for the number of executions. Getting that Swagger is an execution. So that is one thing to think about. If you're going to have something that's going to be, a lot of requests to it, you do have to think about that. It does go back to your cost. All right, because I am running out of time, I'm going to go real quickly. The other thing I wanted to show in code is if I go to this other Azure function, now this is in preview, and I got to admit, I don't actually like it, but they've built in this SQL, Azure SQL trigger and binding. So now I have this, you see I'm calling the SQL and I'm actually executing the SQL I want to execute. You notice I'm actually passing the command type, so it can be a store procedure or what have you. It is using parameters, so you can prevent the dependency or SQL injections. So it's an interesting way of doing this. Like I say, this is in preview right now. This is not something I will be using, but I think it's interesting to look at. I will say Microsoft's working on something else that I can't talk about, but it is pretty darn cool, tied with Azure SQL. All right, so real quick, some quick best practices, because I have like 2 minutes left. Number one, avoid long-running functions. I talked about that, an Azure function in consumption mode at most could be 10 minutes anyways. But even then, really, if your function is going to run more than 3 or 4 minutes, Azure functions might not be the right thing for you, because there is some things that you have some weird things happen. Now, with that being said, there's an extension called Durable Functions that actually will allow a whole lot better way of doing it. You want to avoid cross-functional communication. Again, you'll have some weird things happen, but also, if function A calls function B, which calls function C, guess what? Function A is running that whole time. It doesn't stop and wait. Now again, there's durable functions that allows you to do that, and it will suspend it. Write your functions to be stateless. I mean, we talked about that's a tenet of both RESTful services, also of serverless. Organize your functions for performance and scaling. So there is no limit of how many functions I could put into a function app. But the biggest thing is you're paying for memory usage. So if I have a whole lot of things in one thing that's not getting used very much, each execution costs me more money because it's going to use more memory for all that. But again, there's no set rule, okay, you do it this way, you do it that way. You just have to play to see where you're going to go with that. Share and manage your connections. It's ASP.NET. You're going to do the same thing, right? You're going to share your ASP connections. You're going to share your any framework connections and so forth. Avoid sharing storage accounts. This is every time I deal with DevOps people, They always want to put, we'll have like 10 Azure Function apps. They want to put everything in the same storage account. Don't do that. That actually causes issues with Azure Functions. And because of the fact you're not paying anything for it, the only thing is now I have 10 Azure storage accounts, but that's not a big deal. Definitely use async code, but avoid blocking codes. So, the wait or the, looking for the result, you definitely want to avoid that. It messes up the threads. And again, because it's a serverless model, it really does cause an issue. All right, so I'm exactly at 1 hour. So sure enough, thank you. There is all my contact information. Definitely feel free to reach out afterwards. I will be around, so if you want to talk about anything we talked about, definitely come find me, and we can definitely talk about more stuff. And with that, I really appreciate you attending my session, and I hope you have a great rest of your day.